we're trying to figure out the digital thread all the way through. And the question goes to the digital twin. What implementation have you seen out there in the industry that has the best example of digital thread all the way through the manufacturing process?
Very honestly, I've not seen any yet. That's why I have, at least not at the level like Grumman, Space, etc., of a highly complex system. I know they exist at the equipment level. If you think of some medical devices or others, they have them there. But it's a problem which is like 3 orders of magnitude simpler than what we have in an aircraft or a missile or a satellite or anything else. But everybody is working on it.
Isn't a way to solve the problem also is that because different organizations within, departments and companies and your IPT teams have different tools, and they use different tools, and you need interoperability between the different tools. And I think that's, to me, an opinion, it's going to be key, because no one's going to select one vendor all the way through.
I can only say yes. You're totally right. This is my concern, and I've been talking about this many times. This interoperability, either at the tools level or the repository level. There's many different ways to do that. Is not easy. Let me be cautious in saying it this way. And the tools industry is not really doing what I think they should be doing, bringing this together within their own suites. I don't want to insult anybody because there are a lot of companies trying to do it, but they're also keeping it fairly well to themselves and not looking to cross an industry standard, part of our problem.
So, one last question. I thought there'd be a line behind me.
If someone's got other questions, go ahead and get the line.
One last question is there a standards body that is going to address that, to the interoperability between tools, so that you export and you can import it into another tool, the digital content?
I'm not a specialist on this one, but maybe I can.
So I can step in here.
Perfect.
The systems engineering organization, INCOSE, when we first started down this path, we discovered that there was no semantic standard for exchanging system engineering types of information, like requirements, for example, and otherwise. There's been a lot of work that's been done over the years. ISO STEP, for example, there's a data exchange standard for requirements. There's a data exchange standard now for system models like states and stuff like that that's now available, ISO 233, for example. But what we found out is that we were so slow in implementing, the automotive industries picked up and they did delivered RIF and RecIF, for example, for exchanging requirements. And other things have happened in regard to that as far as the data exchange standards. Others we made a good shot at. So for example, SysML does not have a decent exchange standard in place. In fact, the big complaint among the aerospace people is they can't get a SysML model to exchange with another SysML tool, even within the same project, because there's no agreement and so forth. That's why version 2 of SysML is getting ready to happen. SysML version 2 is not necessarily a language anymore. It's a common data model with a common set of APIs that enable exchange of information. It's going to solve a lot of problems. But we're working that direction, and there's progress being made. If you want to get involved with that, you want to get yourself tuned into the, I think is John Nallen in here still? There's a working group called Models and Exchange Working Group, okay?
Great.
So get involved with that. Thank you.
Thank you for your time. This was a great format.
You're welcome.
Thank you.
Chi, you want to step up?
Yeah, thank you. Very enlightening talks. And Heise, I always love your talk. My question is for Ron. The methodology you have, derived architecture, framework architecture, the message really resonates with me and many of my colleagues. Hopefully someday we don't need to write requirements. That's probably not going to happen very soon. And the question is, did you develop that methodology while you were Boeing? Is that when you were there? And then if that's the case, have you have a use case, an actual example of using that method in the real mission of program?
So while I was at Boeing, and I retired in 2015,
Yes.
so we actually had a design for implementing structured requirements from the architecture model
Right.
into the requirement. There was a design with respect to a particular MBSE tool, but that was never implemented.
Ah,
So what I showed you, and that's described a bit in the patent that I referenced as being based on the Boeing work. In the example I showed you using core, that was developed by me after I left the Boeing company, and as I said in the presentation, it doesn't have an automatic rendering of the information in the architecture into the requirement, although one can put those two diagrams up together to see whether there actually is a relationship between what's in the requirement and what's in the model, which is how I use it. There's at least one tool provider out in the exhibition hall, so here's your scavenger hunt. Go find tool providers and ask them, hey, do you have the capability to render a requirement directly from the architecture model? Because I don't know what's out there. And that would be a good exercise, and that way all the tool providers will get a lot more traffic and they can explain what they've done. But I know there's at least one that has it.
okay, thank you.
I think the critical question is, can you get the t-shirt, shall be?
You know, somebody can go for it, because I haven't made that one. And you're welcome to use that phraseology if it's useful.
Go ahead, Ray.
Thanks. Do you know of any research that's been done in, let's say, qualification acceptance of parts in highly regulated industries, the military defense, government procurement, for instance, product acceptance using MBSE? So specifically, we have to create 2D drawings despite using MBSE. Eventually, we crank out Word documents and flat drawings to give to our customer, and then the customer would do a compliance check on a subset of that. Is there a way to do this all in the model where everyone is on board? And if so, have you know of anyone doing that or explored that?
Yeah, and my company has done some work and for the Air Force for mission assurance, which includes things like part certification for space qualification. We've also done some model-based nuclear surety design, and this morning there was people talking from Sandia who were involved in some of that. Sure. So we've done some, but it's more on the kind of applied research, and it's still in the early stages.
I just add Gulfstream, the 650, the FAA is looking at using the CAD drawing as a substitute for 2D.
Oh, gotcha. Okay.
So the trajectory was set by the 78 or the 777 in terms of using CAD as the basis.
Gulfstream 6. Okay, I'll check.
Yeah, we can have a conversation. Go ahead, John.
I would need some additional explanation on the what you said on requirements with the use of the IFFPD, in addition on the fact that how would you demonstrate that requirements are sufficient, necessary, etc., based on simulation on the IFFPD, because more or less it's an animation on what is describing it, so more or less it's an animation on some stories about the way the system behave, and if there are some conditional branches, it's some stories, but it's just some stories. So I don't really see how to demonstrate those properties of the requirements out of having more a complete architectural models and formal proof analysis things.
So I may not be fully appreciating the question the way you're asking it, but let me try for an answer, and then you can
the rest of the presentation.
then we can have a feedback mechanism, and you can tell me whether I need some course correction. So one of the ways I specifically have my graduate students use their models is first to prove that it actually executes, that they can get information from one function, which is tied to some node, successfully delivered to another function on another node via some actual link, in a timely manner so that the next function can execute, and that there's some combination of functions that collectively will satisfy some higher level timing requirement, for example. And that's fairly straightforward in the use of core from Vitek. That's about as far as I go in the simulation regarding model validation. Does it execute to completion? Can I start with some event, some initiating event, perhaps an input from a user, for example, or some other triggering mechanism, and will it run to completion and go through all the functionality that's built into the model, and will it satisfy critical timing requirements that are part of the system definition, the requirements at a higher level. As far as individual performance attributes associated with some of the functions, what you can do there, of course, is going to depend on the specific modeling tool you have available, and more of the architecting tools have plugins or links to things like MATLAB, Simulink, and so forth, where you can exercise other kinds of parametric models to validate that when the function is performed, it actually has the correct performance attributes other than just timing. Does that help?
Yeah, I think the real point is what you said, the combination of potential solicitations and having the complete map of all the potential solicitations. So I would be really interested to discuss it afterwards with you.
So have a conversation with him.
Yeah,
There's your
thank you.
shot.
So I don't believe the models will ever automatically tell us if all of our requirements, if they're complete, correct, and consistent. Except, at least not for the complex system that all of us work on. But we must not forget that the modeling is there to help us do engineering better. We still have to do the engineering. And the modeling can check for certain things, and part of the modeling ecosystem, let's talk some of the enablers, are developing some validation checkers. Let the machines do the validation that machines are good at, but let the engineers do the validation that requires a lot of really hard thinking and engineering knowledge.
Next question.
I just wanted to say thank you for the examples that showed how to draw and create a relationship between the model and the requirement and the syntax and the patterns, because I just spent a lot of time last week trying to figure that out with my team, so that was super relevant. The question is for you. You put up some timelines about the adoption phases of bringing model-based development and the digital thread into the organizations, which I thought was really interesting. And I'm just curious what T0 is relative to those timelines that you've set up, and what maybe, if you talked about in that conversation, specific catalysts for triggering those events to start to become more active.
Well, that's a big question. Let me just go back to what we did. We had a very intelligent panel together, which came from automotive, from aerospace, from academia, etc. And I was using a Delphi method to have them give me your opinion on it. When do you think what could possibly happen? Now, each one of them spoke from the background of their own organization and from the background of where they are in the planning or execution of any of this digital developments. And the spread which you saw in this chart is very huge. And it comes exactly from the different degree of emphasis that people put on this whole transformation. I don't want to be too specific, but the emphasis that you find across the industry on digital transformation and the degree of understanding and execution is massively different. And for my own
wasn't T0 though January of this year?
Yeah, the T0 was January. Yeah.
That was done in January.
Yeah.
The event was in January.
Yeah, it was in January.
But the numbers then were representative of the time from that specific
Exactly.
point. Perfect.
But take them, as we say, across your two fingers.
Yeah, and it's
They're an
relative.
indication of where things are.
Does it come down to leadership support, do you feel like? Or business understanding of the need that drives the timeline?
Absolutely. That's a key issue. Has the top understood that the company needs to transform or not?
Thank you, appreciate it.
guess-
Just to throw
go ahead.
something in on
Go
the, I
ahead.
don't know, young business student here. So, then, like, what I'm picking up on leadership support, and from my experience, I'm noticing leadership support generally comes when you say this idea will make more money than this other idea. So, I think the leadership support is a lag indicator of market availability of a product that can actually tie the digital thread all the way across. So you're hoping that those 5 to 8 years, depending on the example, is relying on some small business or somewhere, some guy sitting in his dorm room or whatever, working late nights trying to develop this technology.
Good point, but it's even worse. Digital transformation costs money, a
Right.
lot of money before you have the return on investment.
Yeah.
Okay, I guess we'll go for our last question
Yeah.
here.
Thank you for that very interesting session. I think the shall be, shall is will stick in my mind forever.
Sorry about that.
I'd forgotten even the original correct word for those. So.
Okay.
But so one observation I had is that in the industry, we do a lot of work, a lot of work, which has nothing to do with requirement. It's nothing to do with needs, requirement, behavior, architecture, or validation or verification thereof. Okay, we do a lot of that. Now, hopefully as MBSE matures, and hopefully long before the 10 years, we will have enough confidence as a discipline, systems engineering discipline, to put our foot down and say, why are we doing that work? If it's not to do with the requirement, or not to do with the behavior or architecture or validation thereof, why are we doing it? It's got nothing to do with the product. The customer, it's not going to impact the customer. So at some point we should have enough confidence as a discipline to put our foot down and say, okay, for example, if you're managing a program or managing a project, you should not be doing anything outside of designing your work breakdown structure or whatever the activities are around this model. Why are we doing any work outside of this? So it's all waste and rework. So so that's just an observation. I'd like to ask the panel, when do you think we will have enough confidence in this MBSE or this philosophy of it? I'm not talking just too much about the tools, but about the philosophy of it. At what point will we have enough confidence to put our foot down and say, hey, thou shalt not do any work outside of understanding the customer need, the requirement, the behavior, the architecture, and the validation thereof, or verification thereof.
It's probably a good final question. Yeah. Say when. Let me give you a data point. When I was working at Texas Instruments, maybe James will remember this. There was a study that was done, time and motion studies, to try to figure out how to make system engineering more productive than they currently were, because we needed 3x more of them to get our job done. We recognized that at the front end of the life cycle were these critical people, but we didn't have enough of them, so how do we make them 3x more productive than they currently were? The initial thought was, well, let's just work them on 2 shifts. It's too late. They're already working 70-hour work weeks as we looked at the labor. But it came out as we did the time and motion studies. We found out probably, I think this number was, 1/3 of their time was spent on fluff. That's what we called it. Fluffy things that, like for example, I changed the requirement and from shall to will, and then the neighbor, shall be, shall I, and the neighbor cube guy came back and changed it back, and the neighbor guy went back and forth. And I remember looking at a database of requirements, and it had changed 35 times back and forth because this argument was going on. And nobody ever knew that argument was ever taking place except those 2 guys, right? But it was all fluffy stuff, and there's probably a heck of a lot more fluffy stuff going on in organizations. I'll let you guys comment.
Well, one thing, that's one reason why I showed you the modeling ecosystem, because you're mentioning the ecosystem is causing us to do all this stuff that's no value. And that's one thing, an enterprise architecture, if you model the actual business and engineering processes in the modeling context, you'll discover there's a lot of things we don't need to do anymore. So, but you have to understand that as a bigger level system, the enterprise itself, the modeling ecosystem.
So let me just add on to that a bit. if we can characterize the problem we're trying to solve, then we can stay focused on solving the problem. That doesn't mean there won't be what appears to be fluff, because one of the two key things we do in systems engineering that I don't think we should ever lose are risk management. And that sometimes involves what might be fluff, because we embark on certain activities that we develop to a certain extent, but we never have to exercise because our initial guess worked out okay and we don't have to branch into a risk mitigation activity. Some might call that fluff. It's just part of risk management. And the second is recognizing that design is a creative activity, and not all designs work out, and sometimes we evaluate alternatives in trade-off studies and consider what we might do. That's not linear and deterministic, at least not yet, and I don't believe we'll ever have a vehicle for pushing a button and automatically generating an approvably optimum design for anything. So it's a creative activity, and because of that, we do evaluation. We experiment and we consider alternatives and so forth. So there are a couple of things about systems engineering that differentiate it from some of the other disciplines that may involve what some people consider fluff, but I consider key elements of our overall capability.
Okay. Anything else you want to add something?
Yeah, no, just a quick question for the, oh, I'm sorry.
I'd like to just add one point on this one. Where I come from in the space industry, we've had some 500 new startups built in the last 10 years, and there are daily more coming to it. You know what they do? They're mostly digital. They don't care about processes. They do systems engineering. They use the MBSE to do the engineering. And then they're either faster, or they have more depth, or both. And that's happening even in government and in big industries. But it's happening particularly in the small industries, the startups, because it's their chance to raise off and be a bit better and faster than the big ones.
Okay.
Just a quick question for the Purdue team. A lot of choreography there. There hadn't been things that were edited out or simplified.
That's a great question. Thank you for asking.
So
all of this,
before you go, we're going to have one more slide. So hang on for just a
in
minute.
Bear's model, there's a huge cybernetic loop that flows from management through coordination down through the acting entities and back up the feedback to management about progress. And you can think of model-based systems engineering as allowing for the coordination and model-based engineering across all those functional entities that are doing the job, and they have to share a common way of doing that. And then we are not focusing necessarily, although someone, on feedback out of model-based systems engineering to management to actually status and progress, the progress towards completion. The loop is not being closed, so management doesn't appreciate it because they can't use it to manage yet.
Okay, let's have a round of applause for everybody else. Okay, we want to thank our august body here. All these presentations were recorded. They will be posted on the INCOSE YouTube channel. I know you guys are going to ask the question. It may take a couple weeks to get there, but they will be there, and you can share it with all your friends on LinkedIn. Presentations will also be available. These presentations are going to be available online with the rest of it. Now, follow up. Troy and I, we do these lightning rounds. It's getting to be bigger and more important all the time. The next one is in the January International Workshop. We're going to put out a call this year for lightning type presentations, okay? And so what I want you guys to do when you receive that, think real hard, think about how you can make it interesting, what you're going to be doing, and come and submit. So with that, we'll call this lightning round. We want to thank you all for being here, and thank everybody for participating. Thank you.